Good evening, welcome to the STEM Shed. Today I'm going to be going over some calculus. So I believe a lot of your kids, or maybe you are a kid, they're probably starting calculus and they're nervous about it. It's a class everyone dreads, but it's actually not a terrible class as long as you understand the concepts that are in the class. So again, my shed's still a little bit disarray. I should be hopefully fixing it soon. So I'm basically going to kind of go off some of my notes today. And we talked about derivative and also go into some examples of things to look for. Mistakes I've made when I was working with derivatives for the first time. They are a little bit on the confusing side. And also, you're going to see something here. I want to say here's an example where you can actually just don't exactly do what they tell you to do first, just to see what it does. All right. So I'm just going to kind of read through my notes here. The first part of calculus is about finding the derivative. A lot of it will be memorizing formulas such as d of x is equal to 1, d of x squared is equal to 2x, d of sine x is arc sine is 1 over the square root of 1 minus x squared, which is a video I go over of how to derive this because it's weird for a lot of students. You went from sine to nothing. But this comes down to the unit circle. Anyways, so in the beginning, you may even pre-calculus, your limits are introduced. So they probably gave your kid or gave you something like this, limit of x as it approaches from the right. Remember, positive means from the right. If it's 0 negative, that would be from the left. So in this case here, it's going over here, so it becomes an infinity. And then they'll give you this. And I did this for a purpose, so you guys should just remember something. So you will be introduced to the definition of a derivative as this. F prime of x is equal to f of x plus h minus f of x over h. Then a limit will be placed on the derivative so that h goes to 0. But plugging in 0 to this, if you put x, put 0 here in place of h, and 0 down here, it becomes undefined. And even if you try and go off this approach here, where it's like, well, I'm not going exactly to 0, I'm going near 0, so this becomes 0.000000000000001. Well, guess what? That's going to be a huge slope because that's going to be like a million, billion, trillion slope. So essentially straight up. So if you're like me, I didn't really understand what h was. It drove me nuts when I first started calculus. But h is another way to write delta x. I guess mathematicians at some point in time felt there's too many delta x's, too many in the formulation, so they came up with something else. I'm sure h comes from something, but I'm not sure. But again, derivatives are interesting. What are derivatives about? They are about finding the instant slope. As in, what's the slope doing at that exact moment, right then, right there. If you're on the airplane and that airplane's taking off, so it's flying up like this, and imagine I'm on a whiteboard, so it's going up like this. You care about the slope at this point. You don't care about the slope up here. You don't care about the slope back here. It's what's here. So that's what you're learning about in calculus, is what's going on instantaneously. Later on, you learn integrals, where you learn about, you can apply it to money. How much money have you made over a certain time period? All right. So this mess right here is what I did last night. We're trying to get this way to put it, but they usually give you a x squared when I do this. But I said, let's just start out very simple. Let's start out with something we all know, the original slope, y equals mx plus b. So remember what slope is. You got rise over run, which is y2 minus y1 over x2 minus x1, and that is equal to m, your slope. I gave an example right here. So you can see 4, 4, and x2, y2, x1, y1, and then 2, 2. I did all this and plugged everything in and gave me a slope of 1, which makes sense because you can see this goes over 1, goes up 1. So it makes perfect sense. And then we would end up writing this formula right here, y is equal to x. Now the slope is always going to be this, no matter what. It's always going to be this. But you can still put it into the definition of derivative because it'll help you understand a little bit more about what's going on. So you can see down here, I have a little bit different. I wrote y is equal to 2x plus 6. Got a little terribly drawn graph right here, but it works. So at f of 4, you get 2 times 6, blah, 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 so you get 15. So actually, I don't think that matters. I was just trying to find a place to go. I chose something. So I start here at 6 because x equals 0, and we'll remember up. All right, so down here you'll see this x naught. It's just kind of a way to say initial instead of x1. It can get confusing. And then you have a change of x. What did you do over here? How far did you walk? You were at x2. Here's x1. But in this case, you can also write it as x naught plus the x, the change right here. So plus the x2 minus x1. And I'll give you a distance right here. So that is going to be a very important feature. So going back to this formula here, I'm going to come back to here. So I'm going to first write down what each of these expressions are, because I'm going to plug it into this right here. Originally I'm going to plug it into this, then worry about that. So you'll see here that I wrote, and you'll see how sometimes it doesn't even matter. But I wrote here 2x plus 6, that's the normal function. Then f of x plus h. And all that's saying is I'm choosing a different y value. My y value is going to be different because I moved my h here. I moved this far to the right, so that means I went this far up. So I have x plus h, or delta x, and I wrote it in here. You can see I was brain farting on this last night. I had to scribble some things out here because I just wasn't thinking as straight as I needed to. I was a little tired from work. So I come here and I put this in. So 2 times x plus h plus 6. Almost forgot my 6. And then I end up writing this here, 2x plus 2h plus 6. So I got these two things. So I put them into my formula here. I put them into this particular formula. So this right here was, and here's, actually I'll go over that later. But you can see here I end up having, I'll write it out. So 2 times x plus h plus 6. All right, so that was this right here. And, oh, and I already did that right there, so we know what's going on. Sorry. So I got all that right here. So I end up plugging it in here into this formula. And guess what? This 2x and then this 2x, they cancel out. This 6 and that 6 cancels out because it's a constant. And the constant shouldn't matter, right? Whether this goes up this way here or here or here or way off the screen, it's going to have the same slope no matter where it's at. All right, and that leaves me with a 2h over h. And guess what? Once that combines, I have 2h over h. So that becomes 2. So my slope is 2. So, and it makes sense. It changes here. But let's step it up a little bit. So I'm going to do another little problem here. So we're going to move to the classic, and this is what they'll probably give you first, the y is equal to x squared for, and I'm going to do it for x greater than or equal to 0, or the first quadrant. So remember this right here, your first quadrant. All right, rewrote the formulations here. So what I want to do is find the derivative of this, and I know what the derivative is going to be, but because I've done this a billion times, but you might as well go through the process. All right, so let's go through this whole process here. F prime of x is equal to, I'm going to start with this one here, so we know x squared. I'm sorry, let me write f of x here. And then f of x plus h. And this will make it simpler, so I will start with this. All right, so we know f of x plus h. Well, this is our formula right here, so this becomes x plus h squared. Now, a common mistake I see is students will do something like this. They'll go f of x plus h is equal to x squared plus h. This is incorrect. But I've done the mistake myself, so it's not anything to beat yourself up over. So, I mean, what all this little bracket right here means is that you're applying, let's keep it simple, like I can make this f of smiley face. All right, f of smiley face. Well, that's a function of the smiley face. So this would become smiley face squared. That's all it would be. In this case, we chose x, so we go f of x is equal to, and this smiley face comes at x squared. That's all it is. So that's what these are saying right here. So putting this x plus h, if you put 10 here, this would become 10 squared. All right, but now we have that out of the way, we can actually work on writing the formula. So f prime of x is equal to, well, f prime of x here, we know is equal to, and let me actually work this out. It's not hard, so x, I'll keep it here. X plus h squared minus x squared. All right, and that is going to be over h. So I'm going back to h. I'll go back and forth on this. I think I now see why mathematicians chose h, because it's just easy to write. So you're coming here, and of course you gotta FOIL this out. So that's going to end up equaling x squared plus 2xh plus h squared, and that's this part right here. I'm gonna kind of put like a dotted bracket just so you can kind of remember. I don't want to really influence what we do. Minus x squared, and that is going to be over h. All right, great. So let's just get rid of some things. So we know we can get rid of these x squareds here. I need a better pen. We can get rid of this x squared. We can get rid of this one here. All right. We have, let's see, nothing else other than we can get rid of this h, and one of those. All right. So that is equal to 2x plus h. All right. Or we'll say 2x plus delta x. All right. That's because I want to use it a little bit later. So 2x plus delta x, all right? And then they'll normally tell you to do the limit as delta x or h goes to 0. So you have this formula now, 2x plus delta x. Well, as this goes to 0, this goes to 0. So your f, let me put my equals here. And that is equal to f prime of x is equal to 2x. All right, so once you have this, you can figure out the slope at any particular point. So I have a graph here that I drew out, and so we know at f prime of x, for, let's say 0. 0 is easy, right? It's right here. You have no slope. It's flat. All right. You have f prime of 1. Now, on this scaling here, you remember I have the different scaling just to fit things and make it look normal. Otherwise, it just shoots up. So this goes 1 to 0 to 7. So 1, 2, 3, 4, 5, 6, 7. And this counts up one by one. 1, 2, 3, 4, 5, or 5, 10, 15, 20, and so on. So it's not going to exactly slope the way it should, so I'm going to have to try and be careful here. But I kind of get the idea how it's supposed to look based on this graph. So if I chose f prime of 1, I would know my slope would be 1. And you can see here, at f prime of 1, you go up 1. In fact, let's see if I can do that here. So f prime of 1, you go up 1 and over 1. All right, down 1, over 1. All right, so that kind of, let's see if I can do the yellow here because I think it'll make more sense. So it basically, and this is, again, not the greatest scale, but it kind of basically goes like that. All right, so that's where that looks like. All right, I'll have to find a better pen that works better at highlighting, but not too much highlighting. All right, now if I chose, let's, for example, f prime of 7, I would be here. So, because I would be up here at, or sorry, f prime of 6. And my slope, right, at this particular point in time, is much steeper. This is my slope at this one's 12. So I go 1, 2, let's see, 1, 2, you see it good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 1, right? See how that's kind of connecting here? That's your slope. So it's getting, you know, it looks pretty decent right there. Your tangent to this point, that's important, remember that from your geometry. So you're at this point, all right? But let's just say I decide to choose a delta h or delta x out from here. Let me get this back. From here all the way to, let's go 6. So this is going to be a delta x. So my delta x is 6 minus 2. Is equal to 4. So I'm sitting here at 6 minus 2, so my delta x is 4 on this particular one right here. So what if I apply this into my formulation from that I got from this f prime? So we've learned that, and I'm going to go back to this formulation right here. So I'm going to say f prime of x is equal to 2x plus delta x. All right, so we got that. So if I go f of 1, all right, that is equal to, and this delta x here, and I want to say delta x is equal to, actually no, I'm going to go 2, all right? And we'll say, in this case though, delta x is equal to 4, all right? So we get 2 times 2 plus 4, that is equal to 8. All right, so let me see if I can I'm starting here. All right, I'm trying to find it. So my rise is 8. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. And my run is 1. All right, and it's 1. All right, so that's kind of the slope is giving me. It's not accurate. Oh, sorry. It's not accurate, is it? So I went up here, came over here. It's not accurate. All right. In fact, let's do a delta x of, I want to do an f of 2 with a delta x of, say, 10, or equals to 10. Let's even go up there a little bit more. So f of 2 is equal to 2, or we'll say 4 plus 10, that's our delta x, that's equal to 14. Wow, that's even more. So we go, so this was 8. 9, 10, 11, 12, 13, 14 over 1. A little bit steeper, right? All right, but what happens if I reduce it? All right, so doing f of 2 again, and that is going to be, and we're going to make the delta x equal to 1. All right, so we get 2 times 2 plus 1, which is equal to 5. All right, so we go 1, 2, 3, and it'll come here, 5, and then over 1. Whoa, look at that. It's almost like a secant line, right? All right, and let's, what if we do f of 2 with delta x equal to 0.01. All right, so that is equal to 4 plus 0.1. All right, so that is equal to 4.01. All right, so we go 1, 2, 3, 4, and then we're going to go over, sorry, gotta go up one more, or a 0.1. So this would be 4. So we're just going up a little bit, and then we're going over 1. Wow, it's just slightly closer. All right, now what if I change my delta x? So f of 2, the delta x equal to 0, as in 0, dead on 0. It does not exist. It is not 0.000001. It is nothing. Well, that becomes f of 2, which is equal to 2 times 2, which is equal to 4. So you go up 1, 2, 3, 4, not a bit over, and you're going to go right here. All right, and that's your slope. Now, because how I'm drawing it shows it like it might be somewhat secant, but again, I'm not being super accurate. But you can see, you know, and if I made my slope here, f of 2 with a delta x of equal to 1,000,000, in fact, let's make it 1,000,000,000. All right, so that is equal to 2 times 2 plus 1, 0, 0, 0, 0, 0, 0, 0, 0, 0 billion. So you end up with, so this is going to equal to a slope of 1 billion, or 1,000,000,004. So that thing would be straight up. I mean, it would just be almost undefined, not quite. It would just be a little bit shifted over here, but for for what we can deal with as humans. That's it. So, all right, I hope that this gives you an idea about what the delta X means. Also, why, if you're ever curious, just try it and just see what happens. You never know what you'll discover. This was actually a pretty good learning experience for me. I always struggle with the delta X, so I think it's worth a shot. Just try playing with things, see what happens. And that's what all your math is going to be. Just don't do the problems, do the motions. That's how you get A's, but not how you remember anything, and why later on when you're, say, in a thermodynamics class, and this is why I'm segueing into, I want to use this as a segue into a thermodynamics from physical chemistry. This is why it's important to understand what they really mean is going on, because you'll be learning about what quasi-static forces or quasi-static states from a Carnot engine, and it's a very interesting concept. So again, got any questions, feel free to message me. Follow me on YouTube, or I should have started with that. I need subscribers because I want to be able to put YouTube/StemShed, and I apparently need 100 subscribers for that. So definitely subscribe, tell other people to subscribe. And again, my tutoring right now is free. Just, and I'll be glad to meet up with anyone in the Charlotte area. Practice safe social distancing. At Panera Bread if they're still open. But again, I'm here to help. Thank you.